Hello, I am Aniket from Tarkashastra Academy. So, this is the basic session for numbers. Before these basic sessions will help you kickstart your preparation. Before going through the numbers actual session, it is recommended that you go through the basics of number. And once you go through the basics of numbers, जो actual numbers का session है, you will find it very easy. ठीक है ना? तो आज इसमें हम क्या क्या देखने वाले हैं? We are going to look at classification of numbers. Followed by that, we are going to look at prime factorization and then how to calculate HCF and LCM. And this is what our target is for today's session. So, classification of numbers. Numbers are broadly classified into two types. First is real numbers. Second one is imaginary. So, numbers which cannot be posted or plotted on number line are imaginary numbers. They say 0, 1, 2, -1, -2. These are this is your number line, correct? This is your number line. Now, on this number line, there will be some numbers जो fraction में रहेंगे, कुछ numbers rational, irrational रहेंगे. But if the number cannot be plotted on number line, then it is an imaginary. अभी imaginary number कैसे? जैसे under root of -25. Under root of -25 is imaginary. Why? Because 5 का square is 25. -5 का square is also 25. तो कोई भी पॉजिटिव नंबर रहे उसका स्क्वायर इज पॉजिटिव, कोई भी नेगेटिव नंबर रहे उसका स्क्वायर भी पॉजिटिव है ना. सो कुछ भी हो जाए, कोई भी नंबर का स्क्वायर हमेशा हमारा पॉजिटिव ही आता है. कोई भी नंबर का स्क्वायर हमेशा हमारा पॉजिटिव ही आता है. तो स्क्वायर रूट भी हमें सिर्फ पॉजिटिव नंबर्स का ही लेना चाहिए. बट इफ वी टेक द स्क्वायर रूट ऑफ नेगेटिव नंबर्स, वी आर इमेजिनिंग थिंग्स. वी आर इमेजिनिंग थिंग्स. अभी square root of imaginary number is what we are imagining. That is why it is imaginary number. है ना? I, which is under root of -1, है ना, is an imaginary number. है ना? So how can I write 6i? 6i is what? Under root of -36. क्यों? क्योंकि I is under root of -1 and 6 if it goes inside the under root will become 36. है ना? So that is why it is an imaginary number. सिंपल सा डेफिनेशन अगर हम देखें तो स्क्वायर रूट ऑफ नेगेटिव नंबर्स और इवन रूट ऑफ नेगेटिव नंबर्स, है ना, इवन रूट ऑफ नेगेटिव नंबर्स लाइक लेट्स से फोर्थ रूट ऑफ -100 इज आल्सो इमेजिनरी. क्यों? एनीथिंग रेज टू 4 इज नॉट गोइंग टू बी -100. एनीथिंग रेज टू 4 इज गोइंग टू बी पॉजिटिव. देन इफ वी टेक फोर्थ रूट ऑफ -100, then we are imagining things and that is why it is an imaginary. सिंपल सा है. ठीक है. So imaginary numbers are those which cannot be plotted on number line and they are generally even root of negative numbers. ठीक है. Imaginary numbers से we get complex numbers. Imaginary numbers से we get complex numbers. Now what are complex numbers? Which have a real part and imaginary part. For example, 10 plus 10i, है ना, it has a real part and an imaginary part, है ना. 6 plus under root of -50 is also imaginary. ठीक है ना. So complex numbers इसके ऊपर we'll be again discussing in the chapter surds and indices, है ना. उसमें हम complex numbers के ऊपर भी आएंगे. बट अभी तो ये समझना है कि complex numbers होते क्या है. तो complex numbers हैं हमारे जिसमें we have real part and imaginary part both. ठीक है. Then moving forward to real numbers. Real numbers are those which can be plotted on number line. Numbers which can be plotted on number line are your real numbers. Simple एकदम. ठीक है. Now real numbers are then further divided into two parts. Rational, irrational. Rational, irrational मतलब non-terminating and non-recurring. Non-terminating and non-recurring numbers are your irrational numbers. For example, 3.42364129 है ना. What is happening over here? Here the numbers are neither recurring है ना. Recurring numbers क्या रहते हैं, जैसे 4.65 65 65 up to infinity. So 65 is recurring over here, no? Yes or no? So here there is no recurrence. Also it is not terminating as it is going to infinity. So those are your irrational numbers. Square root of prime numbers are irrational numbers. And the square root of prime numbers is always irrational. And जैसे under root of 2, under root of 3, under root of 11, under root of 37 will always be irrational. Then the next best, the most famous value which is also an irrational number is pi. है ना. Pi ये बहुत famous value है and it is also irrational. ठीक है, because its value is approximately equal to 22/7, not exactly equal to 22/7. Now moving forward to rational numbers. Rational numbers either terminating or recurring. These are your rational numbers. Terms which are either terminating or recurring are your rational numbers. Now rational numbers like 3.482 terminate हो गया तो rational number हो गया है ना. 151 terminate हो गया तो rational number हो गया. ठीक है. Then 3.424242 it is recurring, so that is why it is also a rational number. ठीक है. Next, rational numbers can further be divided into integers and fractions. ठीक है, integers and fractions. Now integers and fractions के भी दो type, proper fraction, improper fraction. ठीक है, proper fraction में numerator is less than denominator. Improper fraction numerator is greater than denominator. Proper fraction का example 3/4. Improper fraction का example 4/3 है ना. Here numerator is greater than denominator. Improper fractions are always greater than 1. Proper fractions are always less than 1. And improper fractions are always greater than 1. Proper fractions are always less than 1. ठीक है. If the fraction is equal to 1, then it is not a fraction. है ना. Now if you say 24/24 is not a fraction because it is already equal to 1. It is an integer. ठीक है. Now integers are then further divided into negative, 0, positive. ठीक है. All the 0 and all the positive integers and whole numbers. Whole numbers are 0 to infinity. From whole numbers we get natural numbers. So all the integers from 1 to infinity are your natural numbers. Natural numbers are then further divided into even, odd, and prime composite. Natural numbers are then further divided into even, odd, prime composite. ठीक है. even और prime composite में है तो अभी हमारा कैसे रहेगा. even odd numbers तो आपको पता है ना. numbers which are divisible by 2 are even numbers. Numbers which are not divisible by 2 are odd numbers. Prime numbers कौन से. they have only two factors. Numbers which have only two factors, 1 and itself. है ना. Numbers which have only two factors, 1 and itself. है ना. Composite numbers more than two factors. है ना. more than two factors. ठीक है. For example 2, 3, 5, 7 all these are your prime numbers. 2, 3, 5, 7 all these are your prime numbers because they have only two factors. ठीक है. Composite numbers are 4, 6, 8, 9, 10 all these are your composite numbers because they have more than two factors. है ना. 4 के factors क्या है. 1, 2 and 4 more than two factors होते है ना. Now 1 is neither prime nor composite. 2 is the only even prime number. है ना, बाकी सारे प्राइम नंबर्स ऑड रहे। ठीक है, टोटल देयर आर 25 प्राइम नंबर्स बिटवीन 1 to 100 के बीच में, टोटल देयर आर 25 प्राइम। ठीक है ना, सो दीज आर, दिस इज द क्लासिफिकेशन ऑफ नंबर्स। ठीक है, मूविंग फॉरवर्ड फ्रॉम क्लासिफिकेशन ऑफ नंबर्स, what are twin prime numbers also known as co-prime numbers, है ना, what are twin prime numbers also known as co-prime numbers, तो वो क्या होते हैं वो देखते हैं। नाउ लेट अस से 24 एंड 25, इसके फैक्टर्स पहले निकालते हैं, क्या रहेंगे 1 2 3 4 6 8 12 24, 25 के फैक्टर्स 1 5 25, so this is not a prime number, this is also not a prime number because they have more than two factors, है ना, but these two numbers are, but these two numbers are co-prime to each other, है ना, these two numbers are co-prime to each other, these two numbers are co-prime to each other because they have only one common factor which is 1, है ना, these two numbers are co-prime to each other because they have only one common factor which is 1। ठीक है ना, so co-prime numbers, they have only one common factor and that common factor is 1, बाकी कोई भी कॉमन फैक्टर नहीं। एक और एग्जांपल ले रहे थे 33 35, 33 के एग्जांपल फैक्टर्स 1 3 11 एंड 33, 35 के फैक्टर्स 1 5 7 एंड 33। ठीक है, इसमें से बोथ दीज नंबर्स आर नॉट प्राइम, है ना, बोथ दीज नंबर्स आर कंपोजिट, है ना, प्राइम नहीं है मतलब कंपोजिट है, बट even though they are composite, they are co-prime to each other because they have only one common factor which is 1, है ना, so remember what are co-prime numbers, we'll use them later in the preparation। ठीक है, एक चीज ध्यान में रखना है, co-prime numbers जो रहते हैं ये any two consecutive numbers are co-prime to each other, any two consecutive numbers are co-prime to each other, है ना, कोई भी आजू बाजू, जैसे 24 25 कंसेक्यूटिव नंबर्स है तो को-प्राइम है, कोई भी लेके आ जाओ, 35 36 कंसेक्यूटिव नंबर्स है, दे विल बी को-प्राइम टू ईच अदर। नेक्स्ट, एनी टू consecutive odd numbers are co-prime to each other, any two consecutive odd numbers are co-prime to each other। जैसे हमने देखा 33 35 consecutive odd numbers है, एक के बाद एक odd numbers है, so they are co-prime to each other, कोई भी लेके आ जाओ, take 39 41, take 55 57 consecutive odd numbers, both will be co-prime। ठीक है, और twin primes। ठीक है, moving forward to prime factorization, है ना, these are the basic things, these are the things which are expected from कि classification of number क्या है, co-prime numbers क्या है, prime factorization कैसे करते हैं, HCF LCM, how to calculate HCF and LCM, है ना, all these things are basic things and it is expected out of it, है ना, but then you might have forgotten those things and that is why we are covering it in basic sessions। So prime factorization is what? First thing is, let us say I want to find out the prime factorization of 24, so what you used to do in school, 24 divided by 2, 12 divided by 2, 6 divided by 2, 3, now this fact 3 is not divisible by 2, so you divide by 3 and you get 1, so you have 2 3 times, so that is 2 cube and then 3 raised to 1। I am interested in this 2 cube into 3 raised to 1, we are not interested in the method। For example, if you ask me to calculate the prime factorization of 72, 72 I know that it is 8 into 9, 8 is 2 cube, 9 is 3 square, 8 is 2 cube, 9 is 3 square। We are interested in this prime factorization, we are not interested in this method, है ना, आप method कुछ भी use करो, we are not interested in that, we are interested in this prime fact, this is your prime factorization। For example, 100 is what, 10 square, 10 is what? 2 into 5 का square, which is 2 square into 5 square. 2 square into 5 square is your 100. Followed by that, what you have, let us say you want to find out the prime factorization of 36. 36 is what? 4 into 9. 4h 2 square into 3 square. This is your prime factorization. We are interested in this final output, not in the process. Okay. If they ask you to find out the prime factorization of 48, you can do something like this as divided by 2, 24 divided by 2, 12 divided by 2, 6 again divided by 2, 3 divided by 3, 1. So 48 is 2 to power 4 into 3 to power 1. 2 to power 4 into 3 to power 1. Okay, and this is your prime factorization. We are interested in this, as I told you. Now, using prime factorization, we'll try to find out HCF and LCM. And using prime factorization, we'll try to find out HCF and LCM. अभी HCF and LCM निकालना है. For example, I want to find out HCF and LCM of 24 and 36. So 24 का prime factorization is 2 cube into 3 to the power 1. It is 2 cube into 3 to the power 1. 36 का prime factorization is 2 square into 3 square. It is 2 square into 3 square. ठीक है. Now let us try to find out the HCF. HCF of 2 cube and 2 square is 2 square. है ना? छोटा power लेना है ना? Try to understand this. We are taking smaller power. छोटा power. HCF में we are taking छोटा power. 2 cube and 2 square. छोटा power is 2 square. 3 raised to 1, 3 raised to 2. छोटा power is 3 raised to 1. LCM if I have to take, I'll take all the greater powers, all the बड़ा powers. Okay, 2 cube and 2 square. Greater power is 2 cube. 3 raised to 1, 3 raised to 2. Greater power is 3 raised to 2. And these are your HCF and LCM. Just solve them. This is 4 into 3, 12. This is 8 into 9, 72. Okay. Let us say there are two numbers. First number is 2 to the power 3, 3 to the power 1, 5 to the power 2. And there is second number, जिसका prime factorization is 2 to the power 4, 3 to the power 2, 5 to the power 1. Now, if I want to calculate the HCF, what is the smaller power? 2 cube, 3 raised to 1, 3 raised to 2, छोटा power, 3 raised to 1, 5 square and 5 raised to 1, छोटा power, 5 raised to 1. If I have to calculate LCM, 2 raised to 4, 2 raised to 3, बड़ा power, 2 raised to 4, 3 raised to 1, 3 raised to 2, बड़ा power, 3 raised to 2, 5 raised to 1, 5 raised to 2, बड़ा power, 5 raised to 2. है ना? So all the छोटा powers will help me find out the HCF, all the बड़ा powers will help me find out the LCM. ठीक है? Now there is one more case. Let us say there are two numbers and their prime factorization is given. Let us say 2 cube, 3 to the power 4, 5 to the power 1. And here you have 2 to the power 4, 3 to the power 2, and 7 to the power 2. Now, if I want to calculate HCF, 2 cube and 2 square. Chota power is 2 cube. 3 raised to 4, 3 raised to 2. Chota power is 3 raised to 2. Now 5 raised to 1 is here. Here we don't have anything. So can I write 5 raised to 0 multiplied by 5 raised to 0? Because 5 raised to 0 is nothing but 1. Anything raised to 0 is equal to 1. No. So 5 raised to 0 is equal to 1. Now that 5 raised to 0 is equal to 1, multiplying anything by 1, we get the same value. And multiplying anything by 1, we get the same value. Yeah. So I am writing 5 raised to 0. Here we have 5 raised to 1. Smaller power is 5 raised to 0. Similarly, we have 7 raised to 0. Can I write 7 raised to 2 over here? Can I write 7 raised to 0 over here? Yes, because 7 raised to 0 is equal to 1. And anything raised to 0 is equal to 1. So 7 raised to 0 will also be equal to 1. And multiplying anything by 1, we get the same value. But it helps me find out the HCF. 7 raised to 2, 7 raised to 0. Chota power is 7 raised to 0. Next is your LCM. 2 raised to 3, 2 raised to 4. Bada power 2 raised to 4. 3 raised to 4, 3 raised to 2. Bada power 3 raised to 4. 5 raised to 1, 5 raised to 0. Bada power 5 raised to 1. 7 raised to 0, 7 raised to 2. Bada power 7 raised to 2. ठीक है? So this is how you can find out the HCF and LCM of the numbers. Okay. Now sometimes what may happen that you might have to find out the HCF and LCM of the fractions. Now what to do in such cases? So let us say HCF of A by B, C by D, E by F, and so on we have to find. It is nothing but HCF of numerators, that is A, C, E, upon LCM of denominators, that is B, D, F. Enough. We'll apply it on the questions as well. We have taken the questions on HCF and LCM of the fractions. We'll apply it here, but write down the formula. Okay. Now let us see if they ask us to find out the LCM of P by Q, R by S, T by U, and X by Y. There can be more fractions as well. 4 fractions, 3 fractions, 2 fractions, कितने का भी हम कर सकते. Then it will be LCM of the numerators P, R, T, X upon HCF of the denominator, HCF of the denominators, which is Q, S, U, Y, and so on. Okay. This is how you calculate LCM and HCF of the. This is how you calculate LCM and HCF of the fractions. LCM and HCF of the fractions. Okay. So ऐसा है. Now let us try to find out the LCM and HCF of these numbers. 420 and 1782. 420. I am interested in the final product. So 420 is nothing but 42 into 10, which is 6 into 7. So 2 into 3 into 7. Sorry. Into 10 is 2 into 5. So 420. Final value is 2 square, 3 to the power 1, 5 to the power 1, 7 to the power 1. Then 1782. We'll have to do it in this fashion. क्योंकि बहुत बड़ा number है. So 1782 divided by 840, 850, then 891. Then we'll have to divide by 3 because not divisible by 2. 891 divided by 3, it's 297. Again divided by 3, 99. Again divided by 3, 33. Again divided by 3, 11. Now divided by 11, 1. So 1782 prime factorization is 2 raised to 1, 3 raised to 4, 11 raised to 1. HCF कितना हो जाएगा? 2 raised to 1, 2 raised to 2. छोटा power is 2 raised to 1. 3 raised to 1, 3 raised to 4. Chota power is 3 raised to 1. Here you have 5 raised to 1. Can I write 5 raised to 0 over here? Yes. So this will be 5 raised to 0. Here you have 7 raised to 1. Can I write 7 raised to 0 over here? Yes, because 7 raised to 0 is 1. And 1 can be multiplied by anything. It will give us the same value. So 7 raised to 0. This here you have 11 raised to 1. Can I write 11 raised to 0 over here? Yes. And then 11 raised to 1, 11 raised to 0. Chota power is 11 raised to 0. Next, what you have LCM. 2 raised to 1, 2 raised to 2. Bada power is 2 raised to 2. 3 raised to 1, 3 raised to 4. Bada power is 3 raised to 1, 4. 5 raised to 1, 5 raised to 0. Bada power is 5 raised to 1. 7 raised to 1, 7 raised to 0. 7 raised to 1 is the larger power. Okay. This is how to find out the HCF and LCM. Now pause the video and solve question B, C, D. And I'll be continuing from here, but you pause the video and try to solve it and then look at the solution. So 36 prime factorization is 2 square into 3 square. 48 prime factorization is 2 raised to 4 into 3 raised to 1. Okay. And we have already done it. 48 is 2 raised to 4 into 3 raised to 1. 36 is 2 square into 3 square. And that is why I'm writing it as it is. What will be the HCF? HCF is 2 raised to 2, chota power, into 3 raised to 1, chota power. What will be the LCM? 2 raised to 2, 2 raised to 4, bada power, 2 raised to 4, 3 raised to 2, 3 raised to 1, bada power, 3 raised to 2. Next is C, 54, 72, 198. 54 is what? 9 6 or 27 2. So 2 raised to 1 into 3 cube. 72 is 8 9 so 2 cube into 9 raised into 3 raised to 2. 198 is 2 into 3 square. 2 into 3 square will be 18 into 11 raised to 1. What will be the HCF? And prime factorization, I'm hoping you will be able to find that. HCF 2 raised to 1, 2 cube and 2 raised to 1. छोटा power 2 raised to 1, 3 raised to 2, 3 raised to 3 raised to 3, 3 raised to 2, 3 raised to 2. छोटा power is 3 raised to 2. 11 raised to 1, 11 raised to 0, 11 raised to 0. छोटा power is 11 raised to 0. LCM 2 raised to 1, 2 raised to 3, 2 raised to 1. So 2 raised to 3 is the LCM. 3 raised to 3, 3 raised to 2, 3 raised to 2. So 3 raised to 3 is the LCM. है ना, बड़ा पावर लेना है. 11 raised to 0, 11 raised to 3, 11 raised to 1. So 11 raised to 1 will be the LCM. ठीक है. Next, what you have? D 62 is 2 raised to 1 into 31 raised to 1. 186 is 2 raised to 1 into 3 raised to 1 into 31 raised to 1. And 279 will be 3 square into 31 raised to 1. And after the record, you can use this method and try to find out the prime factorization of 279 and 186 all. ठीक है. तो अभी अगर हमको देखना है व्हाट इज द प्राइम फैक्टराइजेशन ऑफ 62 186 279 इसका प्राइम फैक्टराइजेशन तो हमने निकाल लिया. HCF 2 raised to 1 2 raised to 1 here you don't have anything so 2 raised to 0 है तो 2 raised to 0 ही आएगा. Here you have 3 raised to 1 here you have 3 raised to 2 but here you don't have anything you have 3 raised to 0 only so 3 raised to 0. Then 31 raised to 1 31 raised to 1 31 raised to 1 31 raised to 1 overall HCF is 31 itself. Then LCM 2 raised to 1 2 raised to 1 2 raised to 0 highest power is 2 raised to 1 3 raised to 1 3 raised to 1 3 raised to 2 3 raised to 1 3 raised to 0 highest power is 3 raised to 2. Then 31 raised to 1 31 raised to 1 31 raised to 1 highest power is 31 raised to 1. This is how you can calculate the LCM of 62 186 and 279. Now find the HCF and LCM of 3 by 5, 7 by 10. Yeah. So HCF of 3 by 5 and 7 by 10 is going to be HCF of numerators 3 and 7 upon LCM of denominators 5 and 10. अभी HCF of 3 and 7 is going to be 1. करके देखो 3 raised to 1 and 7 raised to 1. तो यहाँ पे 7 raised to 0 है, यहाँ पे 3 raised to 0 है. छोटा पावर 3 raised to 0 यहाँ पे छोटा पावर 7 पे छोटा पावर 7 raised to 0 which is 1. So HCF is 1. LCM of 5 and 10 है ना, we have to take the LCM of the denominator. LCM of 5 and 10. So you have here you have 5 raised to 1 and you have 2 raised to 1 into 5 raised to 1. So bada power 2 raised to 1 here you have 2 raised to 1 and here you have 2 raised to 0. So bada power is 2 raised to 1 5 raised to 1 5 raised to 1 bada power is 5 raised to 1. So this is 10. This is 10 1 by 10. ठीक है कि नहीं? So this I will calculate HCF and LCM of the numbers. ठीक है. If they ask me to calculate the LCM of that is 3 by 5 7 by 10. Okay, 3 by 5 7 by 10. I'll have to calculate LCM of 3 and 7 upon HCF of 5 and 10. So 3 raised to 1 7 raised to 1. LCM will be 3 into 7 that is 21. HCF of 5 raised to 1 into 2 raised to 0. तो HCF हाई छोटा पावर लेना पड़ेगा 2 का, तो 2 का छोटा पावर 2 raised to 0 and 5 का तो 5 raised to 1 ही है. So that is 5. So 21 by 5 will be the LCM. This is how you need to calculate the HCF and LCM. ठीक है. Now pause the video, try the second question. I'll be continuing from here, but आप pause करो, try करो, फिर solution. Second question is 8 by 21, 8 by 21, 12 by 35, 32 by 7. So let us find out HCF of 8 by 21, 12 by 35, 32 by 7. Okay, it is going to be HCF of the numerators, which is 8, 12, 32 upon LCM of the denominators, which is 21, 35, 7. Abhi 8 is what? 2 cube. 12 is what? 2 square into 3 to the power 1. 32 is what? 2 to the power 5. ठीक है, तो HCF कितना हो जाएगा? 2 क्यूब 2 रेस टू 2 2 रेस टू 5, सबसे छोटा पावर 2 स्क्वायर है ना. 3 रेस टू 1 भी है, 3 रेस टू 0, 3 रेस टू 0, सबसे छोटा पावर 3 रेस टू 0. ठीक है, तो ये तो HCF आ जाएगा. अपॉन LCM निकालना है मेरे को. 21 which is 3 raised to 1 into 7 raised to 1, then 35 which is 5 raised to 1 into 7 raised to 1, and then 7 which is 7 raised to 1, है ना. तो LCM निकालना है, तो हाईएस्ट पावर ऑफ 3 will be 3 raised to 1, क्योंकि बाकी जगह 3 raised to 0 रहेगा. हाईएस्ट पावर ऑफ 5 will be 5 raised to 1, and highest power of 7 will be 7 raised to 1. तो ये कितना आ गया? 4 upon 3 into 5, 15 into 7 is 105. 4 upon 105. Next is HCF LCM. ये अपने को निकालना है. But अभी now let us try to find out the LCM of the given fractions. LCM of 8 by 21, 12 by 35, and 32 by 7 is going to be LCM of 8, 12, 32 upon HCF of 21, 35, 7. ठीक है, अभी 8, 12 एंड 32 में LCM निकालना है. तो हाईएस्ट पावर इज 2 raised to 5 and highest power of 3 is 3 raised to 1. So 2 raised to 5 into 3 raised to 1 upon HCF निकालना है. तो हाईएस्ट पावर ऑफ 3 नहीं, लोएस्ट पावर ऑफ 3, छोटा पावर इज 3 raised to 0, लोएस्ट पावर ऑफ 5, छोटा पावर इज 5 raised to 0, 7 का लोएस्ट पावर इज 7 raised to 1. So this is how much? 32 into 3, that is 96 by 7. This is how you can calculate the HCF and LCM of the fraction. So here we'll finish the basic session of numbers, first basic session of numbers. We are going to record one more basic session of numbers in which we are going to explain the number system. So that will be the following session. If you have any other query, you can connect on any of these social media platforms or visit our website tarkashastra.co.in or send a WhatsApp message on any one of these two. Thank you so much. Jai Hind.